Members, remember, these are members, okay? They are all trust members. These are two-member force, okay? Two-member force, why call it two-member? Because there are 2 points where the forces are applied. No force at the center, okay? Remember this, two force members. Trusses are made of two force members. Okay. Even if you look at this joint, it is at the joint. There's another force here for this member, it is at the joints, the forces. There's no force acting on the member directly, so it's at the ends. Okay. Zero force member. Before we indulge in this, let me okay. What I want you to do is to draw the free body diagram of pin A. Can you do that for me? Draw the free body diagram of pin A for me. Can anyone tell me how many forces are acting on pin A? Pin A only. How many forces?
There are two-member forces.
So say again.
2-member forces, sir.
There are how many forces are applied on pin A?
2, sir.
2. Okay. So one is, I guess, this one, and the other is, I guess, this one. Am I right?
Yes, sir.
Yes,
So
sir.
I can do this, or I can do this. Am I right?
Yes, sir.
Okay, so let's stick to this one because it's easy for me to explain that. Okay, so I've got a force because of member AB here, and I've got a force because of member AF here. Am I right?
Yes, sir.
Yes, sir.
Now I want you to find the force AB and AF. Apply equation of equilibrium on point A. Tell me what is the force AB and AF?
Both are 0.
Say again.
They're 0.
Anyone else?
They're 0.
0, sir.
Is there anyone else?
Yes, sir. It should be 0 because.
So what you did, you made the free body diagram of point A, and on that you apply the two forces, and then you apply the equation of equilibrium. So sum of all the forces along horizontal means AB is 0. Sum of all the forces along vertical means AF 0. Am I right?
Yes, sir.
So what's the benefit of member AB and AF? Is there any benefit of AB and AF in this structure if they are not carrying any force?
If they're just there to provide support to make structure more stable.
So if for analysis, if I remove those two members, will that be okay?
I think that then the structure.
Then the soil. For my analysis, if I remove the members AB and AF from my free body diagram of the whole system. Is that okay?
They cannot be removed
No,
because
sir.
they will unbalance at points B and F.
So do you want me to leave it there?
Yes, sir.
Okay, let's say I leave it there. And I want you to draw the free body diagram of pin F. Okay, so let's see the free body diagram of pin F. I make F. I am sticking to your suggestion that we leave AF there. So let's draw the free body diagram of pin F. So pin F is supported, is pin connected. So there's a reaction force from the support. So I will have Rx and Ry. Is that okay for reaction? Because it's pin connected with the support.
Yes, sir.
I will have another force here, the direction of which I am assuming is Fe. And this, so I'll write F here. And there's another force here, which I am assuming direction and is Fb. And there's another that you do not want me to remove, and that is AF. Is that the free body diagram of pin F? Am I right to say that's the free body diagram of pin F?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, now I'm going to start the analysis. I will do sum of all the forces along Y. Okay?
Excuse me, sir.
Sorry?
Sir, kindly make us all attend.
So come again? I
सर
didn't
हमें
understand.
सर हमें attendees बना दें
One
कि
is
कोई
quoting
जो
us.
ना
Kindly
हाँ कोई
make
बार
all
बार
attend.
मीटिंग से किक कर रहा है स्टूडेंट्स को.
Like random people from the group, from the meeting.
How to do that? What do you mean?
Like
सर participant tab में क्रॉस के साथ 3 डॉट्स होंगे वहां पर मीटिंग सेटिंग
The only option I'm having here is.
सर सही
Yep.
है ये हो गया.
That okay? Okay.
Yes, thank you.
Okay, so I was discussing free body diagram of pin F. So on pin F, I've got 5 forces acting, and I've started my analysis by first looking at all the forces acting in the vertical direction. Okay, and according to you did not want me to remove the AF. So when I do the analysis in vertical direction, what will be the value of AF when I do the so all the forces along vertical direction for point F? What is the value of AF?
0.
0. So why are you not allowing me to do this? Does it make sense now?
Yep.
So if the member has got 0 force, why you want to draw it? The value is 0. Why you want to make things complicated for yourself? Is that clear?
Yes, sir.
Okay, so for the analysis, we are not looking at the deformation of the structure. We are doing the rigid analysis of a structure. Okay, so if a member has got 0 force on it, it means the structure is stable and there's no force on it. maybe the question is why they had this member there then. Why they had this member? Maybe because they want to apply a very high force somewhere here in the future. So maybe that's the reason they wanted to have this support. Or maybe they wanted to have another support here in future. So therefore they may have the member. But for the present condition, when I asked you to do the analysis on this system, you just do it on the system. And the system clearly tells me, because you've done your free body diagram for point A, and clearly tells me this is 0 and this is 0. So why I should get rid of those two members? Because it does not appear in any of my analysis. Is that right?
Yeah.
Okay, so let's go through some of the text here.
Excuse me, sir.
Yep.
So sir, for this particular case, it is okay to remove AF and AB altogether.
Yes. Yes. Let me go through the slide and everything will get cleared. Okay. Okay. So that's the free body diagram of pin A, and you can clearly see it is the 0 value. So for the force along X, Y is 0. Now, let us look at D, point D. I'm looking at point D, okay? Point D, and I've got a force here, member force, and I've got another member force here. The direction I'm assuming, I'm drawing the free body diagram of point D. Okay, because there's an angle here, theta. So let me have my axis. That's my X, and this one is my Y. So I can split, can I? No, let me get it in another way so that would make sense. Yes. Let me draw it in another way so that it's a bit easy for you to understand. I am making my x-axis and my y-axis here. So my DC component, this is my DC component, will have a component here and a component here. Am I right?
Yes, sir.
Yes, sir.
I split DC into two components. This one, so this one and this one. Now, I want you to do the sum of all the forces along y direction equal to 0. So what will be the answer of this DC, which is the y component? What is the value of DCY? This one.
0, sir.
0.
Yes, sir.
Sure?
0.
Yes, sir.
Yes, sir.
So which means my DC is equal to 0. Am I right?
Yes, sir.
Yes, sir.
No, sir.
So my DC is equal to 0. Now I want you to do the sum of all the forces along X and tell me what is the force on DE.
Sir, it's 0.
It's 0. Okay, which means that this is also a 0 force member. So in this structure, we found 4 members which are zero force members. I'll go into the details just a second. Stay with me, okay? Let me get rid of this. Everything will get cleared. How you find those zero force members. So in simple words, it says here, a trust analysis using the method of joints is greatly simplified if we can first identify those members which support no loading. These zero force members are used to increase the stability of the truss during construction or to provide added support if the loading is changed. Okay. In your present condition, when you are doing analysis, there is no use of those members. Remember, this is very important, okay? Remember, this is how you're going to easily find the zero force member. It says here, if only 2 members form a truss joint and no external load or support reaction is applied to the joint, the 2 members must be zero force members. So in this structure, find me a joint which has got only 2 members, and on that joint there's no external force or there's no support. Let me look at this one. At this one, at B, I am looking at B. At B, I've got 1, 2, 3, 4 members. No, forget this. I need a joint with 2 members. Let us look at C. I've got 3 members, not a good one. E, I've got 4 members. F, I've got 3 members and a support. If F was something like this, that's a member and this is a member. Then I had 2 members, but there is a support here. For a zero force member, it clearly tells you that 2 members form a truss joint and no external load and no support reaction. So there should be no external force and there should be no reaction force on that member, on that pin. And the pin should have only 2 members. Therefore, if you look at A, on A, pin A, there are only 2 members. There's no external force. There's no support at A, which means that the 2 members are zero force members. Look at D. On point pin D, there's no external force. There are only 2 members and there's no reaction support at D, which means the 2 members are zero force members. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay, so remember, in a truss, you need to find a pin which has got 2 members, no external force and no reaction support. And the 2 members, you can get rid of it. Okay, the other one. Okay, let me ask you, let me draw a, let me pick it from here, D, okay, D. Let's pick point D. I'm picking point D. I've got 1 force member here, 1 member here, and the other member here. I can put the angle direction which I assume. So pin D, I've got 3 members. I'm drawing the free-body diagram of the. Can you hear me?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So this is the free-body diagram of pin D. Am I right? There are only 3 members on it. Is that clear?
Yes. Yes.
Okay.
Yes, sir.
So let me have my axis. I will have my x-axis here, and I will have my y-axis here. Now I want you to do, so this is DE, this is DC, and this one is DA. Okay, I'm just writing, and they're not vectors, so don't follow the arrow, just abbreviations. Okay, now I want you to do sum of all the forces along x-axis and tell me what is the value of member DA.
Zero.
It's
Zero.
zero. It's a zero. Okay. Doesn't make sense. Let us
Sir,
now
how it is
look
zero?
at C. I want you to draw the Fibonacci. Let's draw the Fibonacci diagram of pin C. Maybe there's some mistake here that it's a zero value coming out. Let's analyze C. On C, I've got a member here, which is DC. I got another member. Sorry, I've got another member here, which is BC, and I've got a slanting member here, which is CA. I will have my x-axis here and my y-axis here. Okay, so let me split CA into the components. So this is the x component and this is the y component. Am I right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now I want you to do sum of all the forces along x-axis. What is the value of CAX?
0.
Zero.
Zero.
Sorry, come again.
0, sir.
Sir, how it is zero? Does not make sense.
Doesn't make sense. Okay. So CA is here. I've divided into two components. That's this one and this one. Is that right? Any issue here?
No, sir.
Okay. So I can get rid of this. Can I do that?
Yes.
Okay. So if I ask you to do sum of all the forces along x-axis, is that the CAX is the only component along x-axis?
Yes, sir.
Yes, sir.
So CAX equals to 0 then?
Yes, sir. Okay. Got it.
Is it clear now?
Yes, sir. It is clear now.
So if one component is 0, because you had this here, remember? So this is 0. So your CA is 0. Is that clear?
Yes, sir. It is clear now.
So in the last slide, we were looking at a pin, where we had two members only, and there's no external force on the pin, and the pin is not supported. So that's basically zero force member. This time, remember, it says here, this is important, if three members form a truss joint, for which two of the members are collinear, means it is in line. Two of the members are in line. Look at point D. For point D, you got two members, this one and this one. They are in line, collinear. Okay. So let me read it again. If three members form a truss joint, for which two of the members are collinear, the third member is a zero force member, provided no external force or support reaction is applied to the joint. You get it? If you've got in a truss, if you've got two members which are in line and the joint, there's no external force on the joint and there's no support on the joint, the third member is a zero force member. Is that clear?
Excuse me, sir.
Yes.
Sir, in future, if we are asked in an examination to find the zero force members,
Yes.
so can we just write this statement, or we need to do the calculations also?
No, you can write the statement.
Okay, sir. Thank you.
Okay.